In this episode, we're making chips again, but this time it's with the Millhead. Let's go see how it goes. In this episode of Werner's Whirligigs, we'll install the tower in the Millhead, assemble the top cover and belt tensioner, tram the Millhead to the table. This is interesting. Make a replacement special T-shaped key to repair the tailstock, and finally, we'll finish up the mill and the series. I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. Hey everyone, and welcome to Werner's Whirligigs, or welcome back if you've been here before. I'm Werner, and you're probably looking at this video right now going, something's different. Something here looks different than the last video. What could it be? Did he used to have a beard? Does he have a new tattoo? What's going on? Well, right here is the Millhead, and it's on here, and it's operational. And following is going to be the story of how we got from the last video to right here. So, buckle up, let's take a ride. We're ready to put the threaded riser together now, and we have this riser. We have a collar, and we have a bunch of ball bearings that are sitting in this tray here. This is really interesting. These negative threads, I guess if you will, are hemispheres, and there's the same in here. These are hemispherical, and so the ball bearings actually ride in here, and essentially the ball bearings become the threads that hold these two pieces together. We have to feed in the ball bearings in the side. We can't just drop them in from the top. So what I'm going to do, there's two ports here. This is going to be the bottom and this is the top. We're going to feed the ball bearings through the top port and rotate it clockwise. Well, I'm sorry, that's counterclockwise. I guess it depends which way you're looking. From the top, from the top it's clockwise. Maybe that's a better way to say it. And hopefully the ball bearings will fall down the track. I'm not going to put any lubrication in right now. I'm going to reserve that for later. And I'll probably just use some type of an oil. I mean, trying to put grease in here and feed the ball bearings down the hole would be a nightmare. You'll probably figure this out on your own, but I just wanted to share my simple methodology for putting in these bearings, or ball bearings, excuse me. I have the two different ports here. This is the bottom port, this is the top port, and so gravity would pull the balls this way if it were vertical. So I have the top port off a little bit to the side so that the balls, when going in, will roll downhill. However, they don't really fall all the way through. You have to give them a little bit of a push, and then they still don't necessarily roll down. So then what I do is I move the collar this way, stick in my screwdriver, and then move it the other way, and that pushes the bearings down further into the cavity for them. Finally, you want to put the screw, or the set screw for this upper hole, back in, and tighten it down. Of course, don't tighten it till it stops, because that will basically fix the collar to the tower. So I just go down all the way. See, now I can't turn, and back it off a little bit. Same with this one. Down all the way, back it off just a little bit, and now they should be set so that the balls can't get past, and that the balls are locked in to the space between these two in the channel. I'm actually having a little bit of tightness in a few places. See, right here it gets tight, and I get past that, and it spins freely, gets tight, spins freely, gets tight, spins freely. I'm going to try taking out a ball bearing. So in order to take out the ball bearing, I'm going to take the top plug out again, and I'm just going to rotate this down and see what happens. Ah, crap. Oh, there. One came out. Perfect. Okay, this is with one ball bearing removed. It might be a minor improvement, I'm not quite sure. I'll try taking out one more. Just removing that second ball bearing made the difference. Now it spins freely, all the way down, no problem. I'm comfortable that we have the right amount of ball bearings in here. For lubrication, I'm going to start with some really lightweight oil that I put on the bearings in my mill. And I'll tell you what that is in a moment. Here's that oil. It's Velicite oil number 10. And I don't know if this is the right thing. I'm just doing it because that's what I put on my mill. But let's see how it works. And I think to apply it, rather than trying to poke it down the port, I'm just going to pour it in here from the top and let it seep down. And then rotate this thing up. And perhaps somebody could comment and let me know what they would suggest using. I may also give Smithy a call and see what they suggest. Well, I did just speak with Smithy, and this machine is pretty out of date. As you guys probably know, it's 7 years old. So the gentleman I spoke with wasn't familiar with this machine. It didn't have a recommendation specifically for these. So I'm going to follow my thinking, which is we'll start with oil. I have to oil it every time it's used, so adding oil to this is no big deal. And if for some reason I don't like that, maybe I'll try grease. So one last thing that we need to address is this little screw here. This is a stop, I believe, and it would stop the collar from raising any further. So I'm going to just back this out a little bit, and then hopefully it stops. Yeah, see, okay, now it stops here. And so, because otherwise you can just screw this all the way up to the top, and then the bearings would actually, well, I don't know what would happen, but it's not what we want. So now we're set. So I received several comments along the way, and one of them was, I'm curious to see what you do when it comes to installing those ball bearings. Yeah, I get it now. And the second one was, boy, putting the shaft, the drive shaft, up into this pulley and getting it through the key is a real challenge. And now I didn't understand before, of course, and now I do. So I think a better method, instead of trying to insert the tower up into the bore and through the pulley and thread through the key slot, is to take this off, put the tower in first, and then put this back down on top. So that's what I'm going to do. The pulley's off. Now we're going to attempt to install the tower into the bore. I'm just putting some of that same Velicite number 10 oil in here just to lubricate it. The only time the tower will be moving in the bore is when you're raising and lowering the mill head. Other than that, it will sit stationary. So I thought about grease versus oil again. I'm just gonna, I think I'll probably just continue to oil it. And as before, spinning this seems to be the trick. Sort of. Okay. Now I'll stand it back up and we'll put the pulley on. I've got the tower inserted into the bore, and I took out the key to test to a test fit with the pulley, and it really doesn't want to just drop on. And looking at the two pieces, the two mating pieces, it does seem to me like this part here is a little, I don't know, slightly mushroomed. So before doing the filing, I've stuffed a rag down in here just because there is a bearing on the top of the shaft, or near the top of the shaft, and we don't want to pollute it with metal filings. I've pulled out the paper towel because I think this is working now. Yeah, let's see, it now just slides right on, no problems. So we need to put the key back in here. I pulled the key, and I found that holding it with a screwdriver, holding it with a pair of tweezers. Yeah, you're not going to be able to see that. Take my word for it. Holding it with a pair of tweezers and guiding it in seems to be the best. The first time I did it, I got lucky. It just dropped right in. But I'm not having that kind of luck this time. So let's see what happens when we drop it on now with the key. I also just cleaned up the edge of the keyway as well. And the last thing we need to do here is just tighten up these cap screws a little bit. And we're done with this part. Well, looky here. We've got a mill head on the machine. Again, I didn't bother showing the mounting. If you missed it in two videos ago where I mounted the mill head on the machine, go back and check it out. I think that would be number 7. And that's when I figured out that the mill head needed to be cleaned up inside, so I took it back off. Anyway, it's on here, everything's together. We need to tram in the mill head. There's no adjustment for this machine at all to make sure this is perpendicular to this table. So what we're potentially going to do, if we need to, is install some shims around here to level things up. This machine came with an ER40 collet set, and I have this nice Noga indicator holder, and then I can just, so that's a 5/16 collet in there. And then I can just put this up in here and tighten it up, and we are golden. Here's a view of this Noga indicator holder and the ER42 collet with an MT3 post that fits up into the mill head. So the idea is we want to see, well, we want to end up with a mill head being perpendicular to the table here. So we just do that by setting our indicator down, and this is actually a 1/10 indicator, or a 5/10 indicator, which I think is too precise to start with, but okay, we've got it on 0 now. Okay, well, so if this is 0, this is off -2 thousandths, -3, -5.5 thousandths. I ended up putting on a different dial test indicator that was a little bit less sensitive. The precision on this one is 0.01 millimeters, which is about 4/10 thousandths per click. I just don't have a test indicator that is less precise than this. I wanted to have the full reach of the arm rather than use a regular dial indicator, because the longer the arm is from here to here, the bigger the arc I can swing, and I wanted to stay on this center bar while sweeping. So you can see the arc that I can swing now. That's probably the biggest arc I can do here. So over right here it starts at 0, and as we sweep across, now we're at 0.1 millimeter, 0.16 millimeters. So this one is low over here, so we need to raise up this end of the mill. So I'm going to put a shim in there and try this again. This location right here is where I am going to be adding shims to the mill head, either on this side or on the other side. I have to loosen the 4 bolts, 2 here, 2 on the other side, and then I can tilt this just a little bit and put the shims in and out. Now I added a 0.05 millimeter shim to the low side over here, underneath the mill head. I'm now getting more sweep. So I'm at 0.13 here, negative 1.13, and now I'm at 0.08. So that's now 0.21. What I'm going to do is take the shim out and move it to the other side. Now with the shim on the other side, the difference is going from negative 0.01 millimeters to 0.1 millimeters, so 0.09 millimeters of difference. Remember, we went from 0.16 to 0.21, and now we are at 0.09. So I'm going to add some more stock to that side. So now I increase the shim to 0.1 millimeters. Okay, a little over 0 to a little under 0. 0.01 millimeters, which is going to be a quarter of a thousandth, I think. I'll have to think about it. It's less than a thousandth, let's put it that way. Now I added another 0.05 millimeter shim on this side here, and let's see what this does. Okay, so it's definitely continuing in the same direction, and it looks like we added 0.13 millimeters, or approximately 5 thousandths of difference between this end and this end. So we're going to go back one step. Of course, we're also curious about how the table is in the left and right direction, 90 degrees to what we were measuring before. We're at negative 0.01 millimeters there, 0, and negative 0.01, 1, maybe 2. And sweeping again in this direction, we're starting at 0.17, negative 0.17, and here we're at negative 0.15, so 2.02 millimeters, which is going to be less than a thousandth of an inch. I think that's the best we can do, given the shims that we have and the level of energy that I have to put into this at the moment. Coincidentally, this ended up being the final resting spot of the shim. Putting a 0.05 millimeter shim here did the best job of leveling the head with respect to the table. And I'm going to cut this off so it's not hanging out anymore. We're really in the home stretch here. I'm going to put these covers back up on top. These get held in by a couple of brackets. And a couple of screws. regarding these clamps here, I think probably if you want to tighten them just enough so they're kind of holding things down, but you don't want necessarily to be tightening them more, just because I think they're gonna pinch if you do. Yeah, it's not obvious either which way's up and which way's down, but I think I have it the right way. And next we need to put in this piece here. This helps take up any slack on the belt. So it's a 19 millimeter wrench. Just kind of tricky to get it in here. This here is supposed to go on the outside of the belt, not inside the belt. We're almost ready to take a cut, and before doing so I wanted to try to figure out the spacing between each of these ticks. It turns out that each tick is 1 millimeter, and so the precision on this is going to be a little bit vague if you were using the dial. Of course, there are other ways to do it with a dial indicator, but for right now I just want to take some cuts and see how the mill works. So I will keep this in mind. This is a 1/2 inch end mill, high-speed steel, and I'm going to use this ER40 collet system to put it in here. I like this thing. I know a couple of my friends use these and they're really great. You can just do so much with so little. So let's go ahead and set this up. First thing I'm gonna do is come over here and touch bottom. Okay, so we got this locked in. Let's, okay, so there we go. And then I'm going to turn the dial till it's at 0. Let's do 1/2 millimeter. And by the way, when the cutting on this mill, and most mills that I know of, the cutting head is going to, or the mill head is going to rotate clockwise. Clockwise on here is reverse, so we need to set the switch to reverse in order for the mill to turn clockwise. So I've got it set up to run at, it's 800. So turn this on and we'll just take a pass across the top of this. I ran out of room because of the lathe chuck. Okay, we'll stop it here and regroup. Okay, now with the chuck out of the way, let's try this again. That's pretty nice. I can only see the arc on this side. I'm not seeing the arc on this side, so I guess that would mean it's not completely flat. If it were completely flat, you would expect to see the cut on the other side as well. But for now, that's pretty good. Before we call this done, there's one last repair that needs to be made. When I was turning that spacer that went inside of the riser tower, the tailstock started spinning, and I cleaned this out and I looked, but I never really paid attention to the fact that there was no key. So there's a key slot here, and I should have paid attention. I don't know why I didn't see it. But there's no key slot. No key in here. And so this thing can spin unless you lock it up. But if you're using the tailstock to drill a hole, you can't lock this down. You need it to be able to move freely. So I looked at the part online. I don't believe it's still available. Not that I would want to buy it anyway, but we have this key stock here that slides, and there's a hole, a vertical hole inside of here. So what I was thinking is I'm making something like this, not that long, but just something short like this so that it anchors into that hole, and then the key will guide this piece. I have to look up and see what this thing is called. So that's what I'm going to do. This groove here is 2.8 millimeters deep, and since this is 4.88 millimeters, let's see, we need to take off just a hair more than 2 millimeters, 2.08 millimeters. So I've got it set up here and zeroed, so we'll just take 1 millimeter at a time and go from there. So I'm going to drop this down 1 millimeter for starts. And yesterday we milled this way. Today we're going to mill this way. Alright, let's give it a shot. The motor is operating in reverse to make sure that the head here is spinning clockwise. Well, that stalled a few times. Let's take a depth measurement here. 3.99 millimeters. So I took off 0.8 of a millimeter. I'm going to blame that on the accuracy of the dial. Not the accuracy, the precision of the dial, because it only has a mark every millimeter. So I'm going to take it down another millimeter. That's looking pretty good. I just turned it a little bit slower. 3.02 millimeters. All right, we're going to switch over to the lathe now. So let me get rid of this this vise. And now you say, what are you going to do with this mill? I'm going to turn it out of the way. And then we'll mount the 3-jaw chuck. Yesterday I drove some studs into this at the suggestion of Eddie the Grouch. Thank you, Eddie. Okay, now I'm going to mount this thing up. The diameter of this is just a little bit too large. I'm not exactly sure how large that hole is. It's a hair less than a 1/4 inch, and a little bit more than 6 millimeters. So as this sits right now, we've got 5.94. Well, that doesn't make sense. Oh, it was a 6 millimeter bolt, so that's going to be slightly finer. I know this doesn't fit because I cut off a piece of it to stick in there. I don't think we need to take off too much, but we do need to take off a little. Once again, I failed with the microphone, but I'll use this time to clarify what I was trying to say earlier. This piece is 5.94 millimeters in diameter, and I tried a 6 millimeter bolt, which is actually 5.5 millimeters in diameter on the threaded part. So the 5.94 was no go, 5.5 was go. So I'm aiming for 5.7 millimeters. Well, I'm set up here on my welding table here, and this is the little dowel that I made, and I took a little bit more off the end to make it narrower than the actual key, so that there would be some room for the welded metal to go. So let's see what we can do. And it's sitting on a magnet just because I figured that would be the easiest way to get it to stand up. And I'm doing it at one end because I'm probably going to have to cut it short. But I'm not sure how much yet, so I'm not taking any off yet. So I'm going to see if I can just tack it. Perfect. That looks really good for what I want. I'm not even going to use any metal. I'm just going to tack it a little bit more. Having a problem with gas though. What is going on? Something's not right. Okay, here's the final product. It's kind of ugly. It has something to do with my welder not sending enough gas down the line. I'm not sure what's going on, but anyway, let's go see if this fits in. And while you won't be able to see what I'm doing in there, I mean, not even I can do that. Let's try. Okay, it's seated on the bottom. So then the next test is to slide this thing in and see if it goes in okay. Alright. Look at that. Problem solved. That's awesome. Ah, that makes me happy. I think this machine is done. The sun is setting this evening, and it's timely because the sun is finally ready to set on this project. This is the 9th video on rescuing this machine, and it's done. Everything is working now. I'm happy with the way it is, and it's time to move on to something different. There will be a 10th video on this machine. I'm going to put this up for sale. as much as I love it and I'm proud of the work that I've done, I don't have the room for it. I have a lathe, I already have a mill, and so this is redundant. But I gotta say, I'm impressed with this machine. The lathe was far better than I could have imagined. I didn't really use the mill all that much, but it was stouter than I had feared. It actually did a good job. So watch for that next video, and it will have all the things that come with it. I got this thing with a bunch of tooling, and I'm going to include most of it in the sale at what I hope will be a fair price. Thank you if you watched this far in the video, and just thank you generally. I really appreciate your company. I will be releasing my next video on the 1st. I always release videos on the 1st, the 11th, and the 21st of the month. So subscribe if you like. You'll get videos on those days. And if you like the content, please leave me a thumbs up. I'd really appreciate it. Alright, well, it's been nice spending the last 9 episodes with you on this project, and I'm looking forward to the next one. So long for now.